All right, so today we're going to talk specifically about Venn diagrams. So there is some vocabulary that comes along with this topic. A set is a well-defined collection, things that are members or elements of the set. Okay. A subset is a collection of the elements that are all contained within another set. If A is a subset of B, then it's written A is a subset of B. It's with that symbol, looks like a sideways U. Okay. An example of that would be, you guys in the back, can we pay attention, please? This is just, this whole lesson, there's no solving, so this is a big part of it, just the explanation. So, for example, here we have A is equal to 1, 2, and 3, and we have B is 1, 2, 3, 4, 5. Therefore, A is a subset of B. That means every element in A is within B. You see how that's the case? Every element in A is within B. Okay, that's why it's a subset. Okay? The intersection of sets A and B is the set containing all the elements that are in both A and B. So for example, if we have set A, which is 1, 2, 3, and we have set B, which is 3, 4, 5, 6, 7, do you see how they have 3, 4, and 5 in common? So when you do intersections, that's what they have in common. Okay, intersections is going to be what they have in common. The union of sets is where you're bringing two sets together. The union of sets is where you're bringing two sets together. So in this case, we have A, B, or A and B. If we're going to bring these two sets together, that means we're basically going to merge them. Okay? That means that every element in A and every element in B is included. Now what you're going to notice is A and B already had 3, 4, and 5 in common, correct? So those numbers, when we bring them in, we don't have to rewrite them. Write them twice. Does everybody see what I'm saying by that? Okay. And then we have something called a complement. That's all the elements in the universal set that are not in the set itself. So let's say we have a universal set 1 through 10, and then we have set A, which is 2, 4, 6. The complement would be 1, 3, 5, 7, 8, 9, 10. It's everything in the universal set that's not in A. Everybody see how that works? Okay. So let's go ahead and do some examples. And then if there's nothing, we would say empty set, which we could write either this way or this way. And then a member of a set, if we want to say 5 is in the set A, we would say 5 is an element of set A, and we use that little E symbol. Okay, so let's go ahead and just start our practice with writing sets. So the months of the year beginning with the letter J. What's a month that begins with the letter J? January. What else? June and July. So those would be all the sets, or are all the elements of the set that would be months that begin with letter J. Set of whole numbers. So what's the first whole number you can think of? Well, we can go even smaller. As you go 0, we could go 1, we could go 2. Could we write all of them?
Yeah.
How long are you going to be here for? Forever? Yeah, so you can either write it like this to show that we're going to continue that pattern, or we have something called, do you guys remember these symbols? I'm going to write off to the side. You don't have to write this. Real numbers. Do you guys remember these symbols? You ever learn about these in Algebra 1? Those weird-looking symbols? So whole numbers is like a W, okay, with this like little, I don't even know how to explain it. It's like doubled, I suppose, with the double letters on it. It's got like, it's like written over itself, right? You see what I'm saying? That symbol indicates we're talking about the set of whole numbers, okay? You'll see that in upper mathematics. So an even number between 11 and 23, could we list all of those out? Yeah, it's a terminating set, right? What would be the first one?
12.
Then?
14.
Uh-huh.
16.
Yep.
18.
Mm-hmm.
22.
And 22. So that one is what we'd call a finite set. Finite means it doesn't go on forever. This is not finite. This one would be a infinite set. Okay, so now we're going to practice our work with subsets. So if we're looking at math teachers at Oviedo High School, would they be within the subset of all teachers at Oviedo High School?
Yes.
Yes. If we were looking at the even numbers between 0 and 10, would that be a subset of all numbers between 0 and 10?
Yes.
Yes. If we were looking at all the quarterbacks of a team, would they be a subset of the basketball team?
No.
No. I actually had asked somebody earlier about one of the teams. It was really embarrassing because we have a question on the homework. It's Orlando Magic. I was like, is that a football team? Yeah, I don't know, guys. Anyways, not my specialty. So I think it was that one. Yeah, there was another one. I know some basketball, but football I don't know anything about. So odd numbers. Would odd numbers be a subset of prime numbers? No. Because even though there are some odd numbers, like 11 and 13 that are prime numbers, aren't there some that are not prime? Like 9 and 15. So, for example, if you can think of one what we would call a counterexample, it's not true. Does that make sense?
Yep.
Okay. All right, perfect. So, this one here, we're going to just practice our skills with these symbols. So this right here, this symbol means that you're looking for what they have in common. Okay, it's an and. So what do these two sets have in common? 9, 10, 11. Perfect. Okay. What do these two sets right here have in common? 3 and 5. Good. What about these ones down here? 5 and 10. So that's what they have in common. So everybody see how that symbol works?
Yep.
Okay. Next one we're going to practice. Okay. Next one is going to be what these sets have if we merge them together. Okay, you're merging. You don't care what they have in common, you're just bringing them together. So it's going to include everything that A has along with everything that B has. And like I said earlier, if they have anything that they share, like for example, you know how they share 9, 10, and 11? You don't have to write those numbers twice. You only have to write them once. This one here would be 1, 3, 4, 5, 6, 7. That's merging the two sets together, right? And then for this one here, we're going to have 5, 6, 7, 8, 9, 10, 15, and 20. So I'm just merging the sets together. So we have any questions about that? All right, so what you're going to notice is there was some typos on there. I tried to fix them, and then I forgot to fix all of it. So do you see how it's like whited out? So this is what it should say. This one here, and I'll talk you through it as we go. So this was a diagram that is a subset, like this. So this is what we would draw a subset Venn diagram like. Now every time you draw a Venn diagram, you're going to put that Venn diagram in a square or a rectangle, okay? And that's because sometimes you have to have things that are not in those sets, okay? So let's, yes. Yeah, you're gonna wanna at least paraphrase to write down what they should be: intersection, union, and complement, and then the notation is important. Those are the most two important parts that you want to get down. So right here, let's talk of an example about this. So let's say I put all of the students in the gym who are freshmen and sophomores, okay? Think of the square or the rectangle as the gym, okay? And then I have a circle on the ground that says sophomores. So all the sophomores are going to go in that circle. And then within that circle, I say sophomores who are in Algebra 2. So within that circle, I have all the sophomores, and then within that, I have all the sophomores in Algebra 2, right? So are there going to be any sophomores in Algebra 2 who are not in that circle? No. But what about all the freshmen? Where are they going to be?
In the box.
In the box, because they don't fall into this category. So that's what the box is for. It's everything that doesn't fall into the categories within the circles. Okay? Here's an example. Let's say I took all the freshmen over here, okay? And then I took all the students in Algebra 2 in B, okay? So freshmen, all the students in Algebra 2. What's going to be in the overlap? Freshman in Algebra 2. What if there was somebody in the gym who wasn't a freshman or in Algebra 2? They're going to be in the box, okay? This shaded region represents the union of two sets, okay? So that's like if I just took everybody and I said, okay, sophomores go in A, freshmen go in B, and then we just said, okay, all freshmen and sophomore. We're just talking about everybody. We don't care whether you're a freshman or a sophomore, okay? But then who would be out here in the box? Upperclassmen, exactly. And then this one is what we call the complement. It's excluding, okay? So let's say we took freshmen in A, and then we had students in Algebra 2 in B. So then I said, everybody can go except for or everybody can go except for the freshmen. So even the freshmen who are in Algebra 2, are they going to go? No, because they would be here, right? But we're excluding them as well. Okay, so that's what the complement is. It's excluding a certain group, a certain subset. Okay? Does that kind of start to make sense to you guys a little bit with the examples? Okay. All right. If you guys need me to come back to get anything down, I'm happy to come back at the end if you didn't get all the word down. Okay, so we're going to do an example of a Venn diagram together. Okay, you're going to label this rectangle U, and then you're going to label the two circles A and B. And then we're going to write the numbers accordingly. So what numbers do A and B have in common?
13, 14, 15.
13, 14, 15. Where am I going to put those numbers? In the middle. And then what's just going to go in just the A section?
10, 11, 12.
Good. And then what's going to go over here?
16, 17.
Good. Okay. So A and B, what's that one going to be? 13, 14, 15. A and B is what they have in common, not to be confused with union, where you bring them together, merging. B complement. B complement is everything in the universal set. So we have every number in the universal set. See how the universal set says A and B? That just means it includes everything that A and B both have. So it would be 10, 11, 12, 13, 14, 15, 16, and 17. So if you want to always write out the union or the universal set, if it helps you visualize it, you always can do that. So anytime you find the complement of something, it's everything in the universal set that's not in this set. So what's in the universal set that's not in B?
All of it.
All of A, except for 13, 14, and 15. So the complement of B is everything that's not in B. Okay, everything that's not in B. Complement can be written several different ways. We either use a squiggly, we use a little C, or we use a little apostrophe. Okay? So, what's everything that's not in A?
Wait, why are 16 and 17 in B?
Oh, you're right. I don't know why that is. That what you guys were looking like confused about? Yeah, sorry. That was my fault. You're right. Does that make more sense now?
Yeah.
Sorry about that. I think that's one of the later ones that we're gonna do. So what up here is not in A?
16, 17.
16 and 17. That's everything that's not in A. Here it's saying the complement of the intersection of A and B. So that's everything that's not in this set right here, because that's the complement, the intersection. So what's everything in the universal set that's not in this set right here? 16 and 17. So that's the one I was doing in my head earlier.
Wait, can you explain that again?
Sure. So see how it's parentheses? Just like with regular math, we work inside out. So we find the complement or the intersection of A and B, which we found earlier, right? Now we take this set and we find the complement of it, which means everything in the universal set that's not in this set.
Okay.
Does that make more sense? Now, see how these ones are a little bit different? See how we're taking the complement before we're unioning or intersecting them? So what that means is we're going to take the union of intersection, or the union of complement B and A. So that means we're going to take complement of B and merge it with A. Okay? Two things with the stars next to it. So, what's that going to look like if we merge those two together?
11, 16, 17.
We're merging them so we can include everything in all of them, right? So I'm including everything A has, right now. Did B complement have anything that A didn't have? No. So for that reason, it's just going to look like A, but that's because B complement had everything A already had to offer, basically, right? So this one here is the complement of A. So I'll erase these so you know which one I'm talking about. The complement of A intersected with B. That means we're looking for what they have in common. So with the ones with the two stars, what do they have in common? 16 and 17. So you're starting to see the difference between these two symbols right here. This one is what they have in common. And this one is when you merge them together, okay? So it can be a little bit tricky as you go through, okay? Try your best. I'll put the video up in a few if you need it, and I'll pass out the homework.